right, we're here. Good morning, good evening, good afternoon, whatever time it is, wherever you are in the world. I'm Malcolm Hawker, the host of the CDO Matters Podcast. I'm thrilled that you've decided to spend some time with us today. I'm also thrilled to be joined by Santona Tuli, who is with Upsolver. We're going to hear a little bit more about her current role. Shantana, you are a data scientist by trade, yes?
Yes.
Wonderful. Well, we had a prep call. I don't know, about a week ago, before we actually got a chance to meet each other this past weekend at Data Day, Texas, which was an awesome day. I think everybody pretty much enjoyed it. I certainly did. But one of the coolest things about Shantana's history is that you're a nuclear physicist. You've actually worked at CERN, like the Large Hadron Collider in Switzerland. How in the world does a data person end up smashing photons in Switzerland?
I think it's the other way around. A physicist, there was first a physicist who was smashing protons and ions together, and then went into industry for doing data. But it was really that that physics was my introduction to working with data. So I don't really think of the two as being separate. So as a physicist, as you're getting trained as a physicist, so it's, through high school and undergrad and all of that, you learn a lot of data skills. So you learn skills around how to make statistically significant statements, and how to make plots and analyze data. So I had that, but then it was really during the time that I worked with these massive particle collision data that I got a true appreciation for um, how hard the data work can be, how many different aspects there are. So part of the work was just figuring out at the hardware software level how to collect data, the interesting data from these massive particle collisions where data is being created at petabytes per second. And obviously we can neither process nor store data at that rate. So it was that's one of the bigger challenges, is how do I even trigger on the interesting events? And then from there all the way through to, how do I maximize the signal to noise ratio? How do I come up with the correct models that describe the signal and the background noises? And then eventually to extracting those signals through generalized linear models. So all of that, and of course, you're writing these programs, and I mean, we use C++ in the particle physics community, and it's a lot. Like the collaboration, it's a global collaboration. All of these experiments are, so your coworkers are in literally in every part of the world. So managing that, all the collaboration software, like there's so much that's similar to data work in industry, especially at the bigger companies with the massive data, that I really don't think of that experience as being like separated from
Hmm.
what I did after that when I switched over to industry.
Well, but so you're measuring things that are not visible with the human eye, correct? I mean,
Correct.
I think you're talking at a subatomic level here. I mean, we're not seeing these things.
Mhm.
So you're I would have to assume that a part of this is you're building models to measure things that cannot be seen, but the models it's based on expected behavior of how these things are actually acting. Yes? I mean,
Yes.
that
So part of
fascinates
it,
me.
yeah, part of it is building models based on expected behavior. Part of it is building models based on observed data. So there's both those angles come into play. And we are measuring the aftermath of the collision, which still is, the particles that are being created, we can't see. That's, very small. But the effect that the particles leave behind in these detectors that we design is really the data that we're analyzing. So we're using that like aftermath data to reconstruct what might have happened in the actual collision.
Okay, so for you data professionals out there who are challenged with data observability, I would try this on for size. This is observability, kind of next level stuff when we're talking about observability. But also, what I'm hearing you say is I don't know. I'm in my mind, one of the big challenges for data leaders, data practitioners, and this was one of the big themes that we discussed in Austin, was this whole idea of measuring value, right? And it's a conversation you and I were both involved in, and during our town hall. It got a little lively there for a while. I went on a little bit of a rant, because that's kind of what I do. But what you just described is like things that cannot even be seen, subatomic level, petabytes per second. Like, holy cow, right? We're measuring that. We're measuring what you said. We're reducing signal to noise ratio. We're coming up with reasonable probabilities of things. Not to say that measuring value is nuclear physics. It sounds an awful lot simpler than nuclear physics, though, right? I mean, I don't know. Maybe I went on another rant here, but if we could do one, I have to think that we could do a before and after on the value of data. Or am I just simplifying things? Like
Well, before and
before, here's where we are today. Here's our business KPIs. Here's where we are today. Here's how efficient our organization runs. Here's how quickly we send invoices, or how fast we recognize revenue, or the length of time it takes us to make something before. Then we do something to the data. We improve our quality. We build an integration. Maybe we deploy a mesh. Who knows? Doesn't matter. But that's the after. Got to think that we could do a before and after. Yes?
well, the tricky thing about measuring the impact of anything is that how do you isolate that impact? So you're talking about a whole entire business, right? There are so many different factors
Mm.
that goes into each of all of those KPIs. I I would be very skeptical of saying over this, 2-month period or even 2-week period, this these changes that we're seeing in our business KPIs are solely due to the changes that we made in our data quality enforcement or data observability. So it's just, I think it's too there's just too many factors that go into it.
Okay, so you're saying a direct one-to-one causal relationship would be impossible.
Yeah.
Okay, I get that, and I agree. But we do live in a world of probabilities, where maybe it's not a one-to-one. Maybe you're just one of many things that could be potentially influencing, but that could
Yeah.
still be meaningful, could it not? If you
Yeah, yeah,
determine, okay, there's these 8 variables that we have through our model. These are the 8 things that actually we think could be impacting business performance. Maybe it's day of the week. Maybe it's whether it's sunny outside. I don't know, but data could be one of those. Can we get to that?
yeah. I definitely agree with that. The other issue that I see though is we're always trying to improve the business. So to
Mm.
this do this experiment, right? This theoretical experiment that we're talking about, would I hold off on running new marketing initiatives because I just want to measure the impact of, something in my data pipeline? I mean, we definitely don't have that level of trust or collaboration across organizations. I feel to actually, carve out that time to make that, especially at startups. I work
That's
at a
true.
startup. It's I think it. We could say I mean I agree with you that in principle you could do it before and after um, some changes that you've made, and that's would at least provide um a uncertainty band. It's how I would call it. Although in this case, like that's the result we're going for the possible effect that this one variable could have had.
All right. Well, I'm not arguing trying to be right. Well, maybe I am, but I do, I do believe that, I mean, either data plays a role or it doesn't, right? And if it doesn't, I don't have a job. So all else being equal, I want to find, even if it's just 5%, right? Like we're even if we said something like, well, we're 80% certain that there's a 5% influence in better data. Heck, I'll take it, right? But I'm not going to be the guy to tell a nuclear physicist that she's wrong. So, it's
I
pretty,
think
it's,
we can iterate on this.
yeah,
After this, I think we should really sit down and try to hash out how to
right.
better measure the impact of a data initiative on the
I,
business.
I think we are agreed that there's no GUT in measuring data value, the grand unified theory of all things, right? We're not gonna figure out how to circle the square, but at least come up with some reasonable estimations. I would hope. All
Yeah,
right, let's.
it's funny the GUT is because I think a lot of the times it is our gut feelings that sort of
Hey, that's
let us pick.
awesome. Well, but let's pick on that a little bit, right? Like people in the data world like to say, "Oh, well, you're using your gut and you're not using data." But where does the gut come from?
Yeah,
The gut comes from experiences.
absolutely. Yeah.
So I think you
No,
could. I
I'm
think
a
you could.
big
Yeah.
yeah.
Go ahead.
I'm a big proponent of heuristics. I don't think, like, even from a science perspective, I don't think we would be where we are today if we didn't have heuristics and we didn't go out and test those theories out and stuff. So no, I've always said numbers are great. Collecting the data when possible. I mean, one thing is that it's hard to collect the relevant data to do whatever measurement you're trying to do. It's not always trivial. Sometimes it can be quite impossible. So you have to rely on heuristics at some level. And I think the more you sort of embrace that and uh, work with the data and heuristics together, or the gut feelings, or instincts and lived experiences together, the better your holistic understanding is going to be. Um, and I was going to say something else, but I forgot.
Well, another. So I mean, yes, all else being equal, we should be using data to make decisions and not just gut. But I wonder, and I'm not trying to be contrarian here. I'm trying to put myself in the shoes of an average leader who has to make a decision like pretty quick, right? And she or he would be given some data. Maybe there's a dashboard. Maybe there isn't a dashboard. Maybe there's nothing. But you got to make a decision now. Maybe you go talk to two or three people, and maybe you didn't actually defer to some known published dashboard, but you did your best in the amount of time that you had to do it. I think you could argue that that's a data driven decision. But I think the real problem, and this is an interesting academic exercise. I think the real problem is that we're neither tracking we're not tracking the decision, and we're certainly not tracking the outcome of the decision. Right? Like in when you were smashing, I said photons, but you said it's not photons. That's light, right? What
No,
were you smashing?
it's protons, and
Yeah.
then also just ions. Yeah.
Okay. When you're smashing them, you know the before state and you know the after state, right? And the decision in that case is the smash, right? And you're able to measure all of these states, which gives you confidence of your data. But in our case, we're not measuring the impacts we're often completely and totally unaware of the decision itself, like a decision has been made. And then we will see the net impacts of some sort of outcome, but we're not really kind of modeling that. We're not following the life of the decision. So there's this kind of growing field of decision science that says that you can do all these things. What do you think about that? Is there some validity to? Are you familiar with the decision science, and do you think there's validity there?
Yeah, yeah, I am familiar. So, okay, first thing, as a physicist, I have to say we don't know the after state of the collision. We are trying to probe the after state of the
Oh, okay,
collision
okay,
and
okay, okay.
see
There's signals though
what's
that
happening.
you mentioned. There's like signals. There's footprints or something that where you get. Okay,
Yeah, we take the footprints in order to analyze, but that's where the interesting unknowns are. That's what we're probing, is what
okay.
happens when you collide these two particles at this energy. Um, so decisions So I think that there's a gap between, and I think you'll agree with this, between data science and decision science
Yes.
today. And I think it's gonna take some time to close that gap. But even when you said, like, a leader is receives data to make decision, right? I mean, I know that's the reality that you can't, as a leader, you probably don't have the time to go work with the data, but it's not enough to be given data, because what does that
Mm,
mean, right? If you're given a dashboard or like a report, which is all you probably have time for, you probably don't get to spend more than 5 minutes, reading up on this before you have to make this call. Is it really enough? Like, because there's so much bias that is introduced by the person that's actually doing the analysis, that's gathering the data, that's giving you the insights, and you're not privy to any of that. And I mean, bias, I don't mean like they're ruining the data or
No, no,
ruining
no.
the
Just
results.
we're
It's
humans.
exactly just working with the data. You introduce your own biases in there. And have you documented your assumptions? Have you documented the limitations of whatever analysis you ran? What's out of scope? What's so all of that you're not going to be able to communicate. At least we humans generally are not able to communicate these when we just provide a stakeholder or an executive with a number or a set of numbers, and they have to make this decision. So it's flawed at the core. It's hard at the core. This idea of being able to make good decisions using data in a data driven fashion. um, and which is why I think, yes, partly the heuristics really have to come in. You have to go with what you've seen and what mistakes you've made in the past. And then the other part is, I think a good leader will have the curiosity to sort of, not just look at a board that someone's produced, but, to, if enough information is in there, to probe and understand and maybe sit with this person and say, okay, you say you did this analysis and this is the results, but can you tell me more? Where, what are the parameters? What did you have control over and what you didn't you? And really try to get the whole picture before actually relying on that data to make decisions. And one last thing is, this is something I was lamenting. I think on our previous call, we don't do error bars in our line of work in industry, right? That's a big miss. It would be so like we would make much better decisions if we did error bars, uncertainty ranges on the results that we were determining and sharing, because cut off numbers, thresholds, it's just your point 0.5, point 0.1 under or point 0.1 over makes all the difference. So what is actually my confidence level on this number that I'm quoting?
That's what you mean by an error bar. Meaning I'm 70% confident that this will drive 20% returns. Like
Yep.
plus
Mhm.
minus some sort of
Exactly.
error rate. Well, that's I wonder how people would react to that, because that seems logical to me, right? But maybe I'm just a little bit too scientific. Maybe I'm just a little bit too analytical. But that seems logical to me because we live in a world of probabilities. Nothing is 100%, right? We live in a world of probability. So this is one area where I think that a lot of data leaders kind of maybe struggle a little bit, in that I think historically we've been really deterministic about everything, right? Like we've been really binary about everything. Either it's good data quality or it's bad data quality. Either we're data driven or we're not great data driven. I don't know if that's an indictment of just society as a whole, or if it's the way a lot of us think. I don't know, but that's not really how reality works. Reality is all probabilities, and that's kind of how AI works as well.
Yeah.
So I don't know. I'm thinking and talking at the same time, but I think there's an opportunity for a lot of data leaders to start thinking differently about their business. And one of them would be, okay, perfect doesn't exist. And maybe we should maybe 60% is good enough. What do you
Yeah.
think?
But I need to know whether it's what my is it 60%? Is it 20%? Like what's good enough, and what sort of uncertainty does a number that you're providing me has? But yeah, I mean it is definitely very challenging. And like one thing that doesn't help is the idea of move fast and break things, which is so much the ethos, especially at startups. And I mean, it's always going to be a trade-off. So I mean, I certainly get it. I'm not saying throw away that mindset and so slow down all of your work, but there has to be a voice of reason too, I think. So this is why I think as a startup grows in the like 30 to 50% person range, and I mean of course it's just it's a generalization. The growth can have different
Yeah.
metrics. At some point you need to have, okay, the R&D team or the engineering team that's sort of sprinting and churning out and putting out these features. You sort of need to have uh, on that in that product org, you need another, the other side of it, the other angel that sits on the other shoulder, right? To
Right.
say, are we? Let's measure if we're doing the right thing. Let's measure if we're moving too fast. Let's um, stop and think about whether that feature that we're so excited about and we're definitely skip even necessary. Let's do the market research to figure it out. And I mean, I think that's so good product orgs do have that. And I think data folks, data teams are in a position to be that voice of reason on the other side of let's just run and produce, produce, produce.
Well, it's all about balance, right? Like it's not just break things, but it's not just analyze forever. It's some happy medium, and that's going to vary. That's going to vary based on your mileage. It's going to vary based on your company. To your point, startups, yeah, let's go break some stuff. Big giant companies, Fortune 100 companies, maybe it's a little bit too much of the analysis, right, and not enough of the action, and try to find some sort of balance there. That's what I've been urging data leaders to do when it comes to AI, because what I've seen is, for a lot of them, not all of them, but for a lot of them, the AI is just kind of unknown, right? It's kind of scary. It's unknown. I'm not even really sure how it works. Seems like a little bit of sorcery to me, and I need to slow down, right? Like that seems to be the reaction of a lot of folks, and it's a natural reaction. I get it, right? What would you say to that data leader that is like, okay, maybe I need to slow down, and maybe they're not reacting fast enough, or maybe they're not reacting as fast as their board would want them to react. What would you say to that data leader?
Yeah, it's an interesting challenge. So it's really hard to separate the hype from the reality, or the hype from the actual advancements that we've seen in the last year ish. Um, LLMs are fantastic, and I mean today we have multimodal models too, that are generative, and the promise and the potential is huge, and I think that's what brings on the hype, right? There's promise, so we must all jump on this ship. But so I mean, I don't it's a hard decision, I think, for every data leader that's receiving pressure from their superiors, from the C-suite, or from the chief executive officer, to incorporate AI somehow into their mandate. um, I definitely resonate with that. Like the pressure is real, and it's a
Mhm.
difficult position to be. However, it's also a time to really be be contemplative about this, because I think at the end of the day, the question that we really need to be asking, as like data leaders of data teams, is what is the natural fit between my product and an AI augmentation or an AI version of this? Like, I can't really force AI into the product if there isn't a natural way to weave that story in. Now, so I work in tooling, data science tooling, and one common way to augment the product with AI is Copilot, right? Code generation, or code complete, in some sense, or having a little assistant that sort of helps you with your workflow, and that's potentially useful, right? With certain tools, at certain scales, is certainly useful. But if you, for example, if you have a low code interface already, and the AI can at best do like 10 different suggestions, because that's like literally the number of ways you can configure the task that you're trying to do, it's not so useful, right? So it's like, what is, because even before you get to the lift, what is the lift of trying to incorporate AI into my product? Is what is it really going to add? And is there a natural story? And if there isn't, then we have to push back. We have to push back on the data leaders and say, hey, this is hype, and I understand you want to do it. And the pressure's probably coming from even higher up. It's probably the VCs and whatnot. But there isn't really a natural story to tell here. No, we could add something that's completely, it's absent in the product today, but would fit more into an AI story. But let's recognize that that's like a pivot, or at least a bifurcation of the product. So yeah, I think for me the biggest thing is asking what the fit is, and whether that fit adds enough value. Um, Beyond, once you get beyond that, and you say, okay, there is some benefit to be unlocked here for my specific product. The next challenge, of course, is hiring the right folks to actually incorporate, and that's also hard. Um, and this is where I say, Like one of the things that I've spoken about previously is like the role definition, defining different data roles. Um, there are lots of ML and AI professionals and folks that really know this space and have the experience. But roles like data scientists, for example, they're neither here not there, right? They're not explaining. So you really have to look at someone's resume and someone's experience and what they're interested in order to figure out if they will be able to incorporate an AI based a practice or AI project or whatever it may be into the product. Um, but I mean, those professionals are certainly out there, and if you I mean, the other aspect of today, where we are today with AI, is a lot of it is becoming turnkey, right?
Hmm.
I mean, for example, these large models, you're not going to train and host them. You're going to probably ping their predict API to get an answer. And that's an easy integration. Like it's still new and you won't find a lot of people who've done exactly that, but it's a relatively easy integration. So yeah, figure out the scope, figure out what value it adds. And once you have that, you just make sure to try to hire that's a challenge too, but try to hire the right people in order to do that integration.
Well, I would argue, does everybody need to run and hire a three, $400,000 a year data scientist? Maybe not. But what you just described is like use a turnkey solution, right? Use something out of the box, like an LLM, whether that's open source, like a Bard, or whether that is an open AI. Find ways to do that. But what you described, I think that there's still some unique work there. When all this started, the craze was prompt engineering, and nobody really kind of knew what that meant. And people were like, "Well, wait a minute, hold on a second. Is this like a really unique standalone expertise?" But where we find ourselves now, I think a year later, is that what I think we're seeing is it's not just well, it may be prompt engineering, but it's really complex prompt engineering where we are doing something to data in order to pass it over to an LLM so that the LLM, so we're passing maybe a known fact set. And maybe that is in a graph or in a vector or in something else. But, OpenAI, the latest version is like 300 pages it'll take in a prompt. So you can pass an awful lot of information in as a known fact set. I think that task in and of itself in doing that, what is known as a RAG pattern, right? Retrieval augmented generation, like doing that work, that sounds like more of a data engineering skill. What do you think?
That's interesting. I'd never thought of it that way. I mean,
How have you thought about it?
I just like I've never thought about whether or not it's a data engineering
Oh, okay,
skill.
okay.
I'm not even a big fan of, I think, necessarily differentiating between data engineering and data science skills. I
Oh,
find more value in differentiating like analytic skills and ML skills, in whatever your role is, either of those fields. But to come back to um, the question of like prompt engineering versus data engineering versus um, all of this. So, I mean, we might not agree on definitions here, but so I think of data engineering as sort of integrating data, bringing in data from different sources.
mhm,
So, but what with prompt engineering or knowing how to, or let's like just in simpler words, knowing how to ask the right question with the
right.
relevant context to an a generative model to get the right answer. There might be some more engineering heavy aspects of that, like how do you build out the retrieval infrastructure for your relevant data? In which case, it's closer to engineering. Um, but from the design aspect, like how do you architect the pattern of providing data and retrieving retrieving information? I feel that's probably closer to a data scientist's um, job, right? So, I mean, I think as with any sort of technology, it's going to be a mix, right? You're going to need different skills that come into play here. So, um, I will just briefly add that I was very skeptical of prompt engineering becoming a thing. So I was like, well, now that we've sort of iterated on that a little bit and sort of, like as you say, RAGs, retrieval augmented generation, like now that we've put more thought into what that really means and what that looks like, I think it makes a lot more sense. Um, the so I am I've had the privilege of working in NLP a little bit, and this is not exactly new, right?
Right.
Like this, the part that's new is these models are massive, and like the scope is massive. But even the generative aspect isn't new. The way that we train models and sort of one thing that that I've done is like a recency bias, right? So you're going to train your model on historical data over 3, 4, 5 years, however you have. But obviously, the context that's going to be most relevant to your model tomorrow is the stuff that is the data that's come in today. So you want to weight that data more. So like putting in that recency bias, things like this, like the architectural patterns that go into how to use NLP to best serve the use case, that's been there. And there is a lot of folks that have been doing this and know how to do it really well. And not all of them are going to call themselves an AI engineer so it's, I guess I'm trying to say that uh, the actual space or the amount of skilled professionals in the space and professionals that can quickly pick up either one set of skills like kind of integrating with the APIs, or the other side of it like architecting the how to do the retrieval is going to be like we're gonna have plenty of people that are going to be able to pick up all of those things. So that kind of like honestly, in some ways we're going back to this idea of prompt engineering being like how to um like, I think of it as, like, knowing how to Google well too,
Right.
like, in some ways, right? So, yeah.
But also, I mean, I think it may go a little bit beyond that, at least for now. I think in the future, a lot of this will be figured out. But our common friend Juan Cicada at Data.World gave a presentation at Data Day Austin where he was talking about using knowledge graphs to drive 30% improvement in the accuracy of LLMs. So I think that's material, right? Where you can pass information, a known fact set in, and pass context, right, into an LLM and improve the quality of the responses. So I think for data leaders, that's attractive because so many are really freaked out by hallucinations, right? Or
Mm.
the creativity or just blatant inaccuracies. And given we do live in this deterministic world, I mean, I do worry that a lot of people are just seeing one or two bad apples spoiling the entire bunch, right? Where they've got maybe a negative experience, or they've seen an LLM hallucinate, or maybe they've put their own name in and asked about themselves, and what they see back isn't quite factual, right? So I think there's promise on the horizon to mitigate that. But let's just kind of shift into a little bit more of a thought exercise. A lot of particularly bigger companies are sitting on a lot of data that is just sitting there fallow, not driving value at all. And I think kind of buried in a lot of the transactional data and a lot of the metadata is a lot of really valuable stuff about how companies perform, what works, what doesn't work. And maybe this is really too high level and too academic a question, but how would a data leader go about utilizing AI to start understand, or utilizing anything? Maybe it doesn't have to be AI. I'd just love your opinion on. I do dashboards today, right? I do some reporting today. I give the business what it wants. I make sure that the dashboards reflect the KPIs that the business is running on. But and I tinkered in the past with Hadoop and big data, and it was a little bit of a train wreck because we couldn't find a use case. But I know in my heart, I know there's unknowns out there. There's a whole bunch of unknowns out there that could transform my business. And how do I go about finding them in a way that doesn't end up with me getting fired because I spent $2 million on a boondoggle?
Oh, that's a really deep question and an excellent question. And I mean, I will start by saying I don't have the answers.
Oh, okay.
Um,
I don't need it, by the way.
but I fully agree with you that there is like, okay, so just breaking things down, right? We collect data about our business to understand how the business is doing. Like the interesting part, the data is just the means. It's not the goal. And we have we always have to make choices around what data we collect because the business doesn't leave a perfect footprint, and even if it did, or even the best version of the footprint is often inaccessible, so it's proxies upon proxies upon proxies, which is fine. Models are representations. So that's it's the best we can do, and that's something we have to accept. However, I really like something you said, like there's so much when you're sitting on so much data and you've done the exercises of trying to figure out which data sources are most important, which ones you combine to get what answers, you're inevitably leaving out some important information. It's just how it is. No matter how well you think you've sieved through the data, especially like metadata, I think folks are talking more and more about metadata
Yep.
these days. But I think for the longest time we haven't been paying as much attention to our metadata. Um, so yes, whether it's hidden in the transaction logs, whether it's hidden in metadata, whether it's hidden in like deeply nested JSON structures. I mean, I feel fairly confident in saying that there is a lot of information that you haven't unlocked because we've also fallen into this pattern of I like to say like there's like 60 questions to answer in analytics. I mean, it's obviously tongue in cheek, it's obviously a generalization, but we've gotten so used to this pattern of okay, I need my HubSpot data, I need my Salesforce data, I need my XYZ, and like really formulaic way of answering those questions. And as we were saying earlier, things are not deterministic like that, right? So uh, I think my answer to your question is it's hard, but it's a worthwhile exercise for sure. I do think with different kinds of information architectures, right, going beyond the enterprise data warehouse or more newer models of newer ways of doing data modeling, I think breaking out of those a little bit and thinking about information architecture anew given the tools that we have today that we didn't used to have. So specialized data source like graph databases, or inverse index like search databases like Elasticsearch, specialized data stores for images and language or vector databases. We have all of these tools at our disposal now, and there are even um, companies that are trying to be the layer on top of all of them, so you don't have to go and integrate your vector database and your graph database. So if we can really leverage that, if we can dig into that and figure out how my information fits in, how I can represent the different aspects of the information that I have in the correct format that's most relevant, most optimized, I think there's a lot of promise there. But it's a lot of work, I would say. And I'm not sure that one would be able to tomorrow go and say, hey, I need, you know, 2 years worth of resources or something to really
Right.
get a better representation of my business. And I mean, then you go to show the value of that, right? You try to project the estimated value, and maybe our lightweight model is good enough, right? What is how much effort is worth getting a slightly better model?
Right. I there's maybe a little bit of a paradox buried in here, in that we started the conversation talking about business value, and if business value is articulated through kind of known KPIs, right, the way we measure the business, those are arguably trailing indicators, right? They're not they're certainly not leading indicators. Maybe sometimes they can be, maybe customer satisfaction. There's a few others, but like they're generally, they're measures of past performance. They're not indicators of future performance. They're trailing indicators. And finding that unknown that could be transformative requires an undertaking that will consume resources, that will consume time, and that will require a lot of experimentation and a lot of R&D. And it sounds, for a lot of companies, that's a bit like a lottery ticket, right? But if you get it and if you land it, it could be like, holy cow. But maybe
Right.
the happy middle ground is somewhere where you just suggested, like maybe more of a knowledge graph, where you run a graph and you learn about a relationship that you didn't know about before, and that you could use that as a way to maybe focus some of your efforts instead of just trying to come up with any correlation out there possible. And this is another reason why I actually kind of like the concept of master data, because it helps you focus your efforts, right? You know, customers are important, right? Like that,
Mhm.
you know your supplies are important, you know your materials are important. At least gives you a place to start looking. So instead
Right.
of it just being a total science experiment where you're just trying to, you know, solve for everything all at the same time. So anyway, this is awesome stuff. Tell us a little bit about Upsolver really quickly. I mean, I'm a big fan because you bought me some beer at um, at Day to Day Texas. But quickly tell us about what your company does.
Yeah, so at Upsolver, we do believe that a lot of your valuable information is locked up in your applications, in your product. So we want to help folks bring in that data into their data infrastructure, into analytics infrastructure, or whatever the use case may be. So we specialize in ingesting streaming data sources such as message buses, event queues like Kafka, Kinesis, etc. So if your microservices are talking to each other, that's generating, that's a queue that's generating a log. We help you ingest that. And then databases, so Postgres, MySQL, all of these different databases that are powering the actual applications that are serving your end users. We're also very good at ingesting that data. You can land it in warehouses like Snowflake. You can land it in lake houses. We have an event coming up next week, the Chill Data Summit, which is all about learning about Apache Iceberg, because we just did a
What day of
first
the week?
class
I'm sorry to
integration.
interrupt, because this what day of the week is Chill Data?
It is on Tuesday. Tuesday,
Ah, okay. This will
February
publish
6th.
on Thursday, so the Chill Data will have already have happened, unfortunately. But for next year, maybe 2025.
Yeah, and also, the talks are going to be recorded
Oh,
and
good, cool, good.
available on
Okay, cool,
demand.
good stuff.
So yeah, we've incorporated Apache Iceberg into our product, so you can also write your data into a lakehouse. Really, however you're comfortable with interacting your data once it's in your systems. Um, we've left all of that open. I think folks often struggle with just getting that data in, because data. I mean, folks often don't even think about those data sources if they're in the, my CRM world and my SaaS application work. So we help unlock the value of your production data.
I've finally just put two and two together. Iceberg, chill. I finally
Yeah.
put that together. I did it just like we had talked about this a couple of times, but it's just like, oh, all right. So, my last question: Are you generally? Is it safe to say you're generally optimistic about AI and the future of AI? Yes. Okay. Yes.
Yeah.
What do you think about the concept of AGI? Where potentially the machines get smarter than us. Do you see that future? Do you see it as imminent? And if so, what do you think of that future?
I don't think it's that imminent. Um, I think that it's a natural I think we're headed that way. But I don't think that we're really gonna get there in my lifetime, maybe.
Hmm.
Um, but there's a lot of science fiction on this. I don't really like to think about it, if I'm being honest. Because, like, I love technology, I love advancement, and I love answering questions, right? This is why I went into science. Like, it's really important to know about the fundamental truths about the universe, as best we can, and model it. Um, but you get like so I'm pro. But, on the other side, like, it's going to be a different world if we get there. I mean, the main thing is the processing power, right? We have our limitations as far as how fast we can do things, but we've been using tools to, augment the way in which we, understand the world. I mean, even a calculator, right? Instead of doing multiplication in my head, I'll use a calculator. So it's not the fundamental concept isn't new. Being able to use a machine that is in some way superior to us, to me, in at least one particular area, to help me do something. Now you generalize that to every area, and it's natural, I think, to feel a little bit threatened. But at the same time, like I think we have to understand I mean, if bad things happen, it's going to be malicious intent of human beings that lead to the bad things happening. So I think we have a little bit of time to get to do this, but I think it's very important for us to start thinking about like how, like, the laws and governance around how to build and how to use AGI, so that we don't end up in one of those dystopian futures.
That's a great way to end. The future is on us. It's on us to try to figure out all of these rules, these policies, these ethics, these everything. So what a wonderful conversation, Shantana. Thank you so much for taking time out of your
Thank you.
busy day. I look forward to seeing you. You going to Data Universe, New York, in April?
Probably.
All right, cool. I'll
Most
catch you
likely.
there. To our viewers, please take the time to subscribe to CDO Matters. Take the time to like this if in fact you did. I look forward to seeing many of you on the next episode of CDO Matters very soon. Thank you, Shantana, again so much.
Thank you
Bye,
so
all.
much. Thank you.